Hey guys, so I'm not feeling well, so I went home, but here is your short version of your lecture today. If you're looking at our agenda, you can see that we're going to take some notes. I believe we're on page 47, 48, so 48 for the notes. Then I have 3 example problems I want you to work through in your groups. And then you're going to finish off without whatever time is left by finishing up the collision simulation activity that we started last week. So let's go ahead and look at our notes. First, let me make sure you can actually see it. You can. Awesome. All right, so don't write this down. This is what we talked about yesterday. Sorry, Thursday, Friday. The idea being is that there are only 2 types of crashes. There's sticky, where you have 2 things that are moving separately, collide, and then move off together. They go from having 2 different velocities to the same velocity. We call that an inelastic collision. That's the type we're going to be focusing on today. There's also a bouncy collision, also called elastic. That's where you have 2 things with different velocities. They collide, and then there's still 2 different things moving at different velocities. Now, the opposite of collision, which we're also going to learn about, is an explosion. So this is when you have 2 things that are together that push off each other and are now moving apart. An example could be someone standing on a skateboard who then jumps off the skateboard. Skateboard goes one way, skateboard shoots the other way, or anything similar like that. All right, now here we are, stuff you need to write down. This should be the top of page 48, I believe. All right, so the entire idea for this unit is called the conservation of momentum. And the idea is that the conservation of momentum says that the total momentum before the collision is going to be equal to the total momentum after the collision. That's what it says. So if here's our crash, car A is going into car B, they stick together and they go off together. The momentum of A is plus the momentum of B must be equal to the total momentum after. Where the momentum of A is going to be mass of A times velocity of A, initial, for before the crash, plus the mass of B times the velocity of B, initial, before the crash. And the final momentum is going to be both masses added together, the total mass, times the total velocity after the crash, final. And the cool thing is that this is true for everything. But today we're focusing mainly on inelastic collisions. Again, when you have 2 things that come together and become one thing and move off together. So whenever you have a problem like this, the first thing you're going to do is I want you to draw it, where you're going to give me the mass and velocity, explosion, masses, velocity. And the reason why you do that is so that you can do this. So let's say that we have a 5 kilogram object, and it's moving at positive 3 meters per second. Plus a 3 kilogram object moving at negative 3 meters per second. That is going to be equal to, 5 plus 3, the 2 masses, times the final velocity. Ooh. So now I can, do some math and say, all right, well, 5 times positive 3, that's going to be positive 15, plus 3 times negative 3 is negative 9, equals 8 VF. Right? So let's see, 15 minus 9. Gee, if only I had a calculator I could use. 15 minus 9 equals 6. All right, so we got 6 equals 8 VF. I divide both sides by 8. And I get positive 0.75 meters per second. Yay! How awesome. Now, an explosion is solved literally the exact same way, but backwards. So go ahead and look at this. See how pretty the picture is? And then I'm literally just going to flip it the other way. Shabam. There we go. So in this problem, it would be more like, okay, well, if I got a 5 kilogram and a 3 kilogram object and they're stuck together and they're moving at a speed of 3 meters per second. Now let's make it even easier. Let's say they're not moving at all. Then they separate. I now have a 5 kilogram object moving at some unknown speed. That's my 3 kilogram object moving at, let's say, positive 3 meters per second. Okay. So that gives me 0 equals 9 plus 5VF. Sorry, AF. All right, which gives me a final velocity of A of whatever, let's see, I have subtract 9 from both sides, so I have negative 9 divided by 5 gives me negative 1.8 meters per second. Yay! That's really it. If you draw the problem, and then you write the equation underneath, and then you plug in your numbers, and then you solve and you put it in a thing where it's something equals something, you end up with an algebra problem you all know how to do. All right, here are your 3 example problems. We will talk about what the answers are tomorrow in class. If I'm not well, you will have another video lecture, and the answers will be in that video lecture. All right, there you go. Get to work.